Hi, today we're going to learn about Cramer's rule. In this section, I will solve a system of equation in 2 or 3 variables using Cramer's rules. I will also find the determinant of a 2 by 2 matrix and a 3 by 3 matrix. Okay, so let's begin. So the first question is, what is Cramer's rule? Cramer's rules is just another technique for solving a system of equation in 2 or 3 variables. So you probably know how to you probably know how to solve a system of equation in 2 and 3 variables by using substitution and elimination. And the other one would be the long one would be using matrices, using Gaussian elimination. So there's another rule, and it's called Cramer's rule. Okay, so that's what Cramer's rule is, just another way of solving a system of equations. So, okay. So these are just what you have to do to find x, y, and z. So if it's a 2 by 2, you're probably going to, or 2 unknowns, you're only going to find x and y. So to find the x value, it's determinant in respect to x divided by determinant. That'll give us your x value. To find the y value, you take the determinant in respect to y over the determinant. And then to find the z value, or the third unknown, is you take the determinant in respect to z divided by the just regular determinant. So what does that mean? How do you find the determinant in respect to x? How do you find regular determinant? Okay, so let's talk about how to find determinant. So the easy one I like to use is the determinant of a 2 by 2 matrix. That's probably the easiest, because all you got to do is just literally multiply this and then subtract that with these multiples. Really, that's really all up to you. That's all you have to do. So that's simple. So the determinant of a 3 by 3 is it's actually a lot longer and it looks kind of confusing, but I'll show you what it means. So what you have to do, so this A11 is this term, right? And you have to this is your coefficient. So it's the coefficient of this number. And then what you're going to do is take the determinant. Well, first, then what you're going to do is cross off any rows or columns that has A11. So what would you do? You could use a pencil or something. I use my fingers. I just cross off anything that doesn't have that is related with that has the rows or columns that has A11. So you would cross this off, and then you're left with A22, A23, A32, A33. So then from there, you could take the determinant of the 2 by 2, right? Okay, and then it's going to be minus this coefficient of this term. And then you're going to do the same thing with A11. You're going to cross off any rows or columns related to A112. So you're left with A21, A23, A31, and A33. And then plus A13, so the coefficient of this number. And then just remember, just cross off any rows or columns that has that number. So you're left with this one, this one, this one, and this one, and then you would just find the determinant of that, right? So I'm only going to do 2 examples because they can be kind of lengthy. So example 1 says use Cramer's rule to solve the system of a linear equation. So you have x, y, you have 2 unknowns, x and y, right? And yeah, it does look tempting to use just elimination, but we're going to use Cramer's rule. So first step in Cramer's rule is find the regular determinant, right? So how do we find the determinant? So how you got to set up a matrix, and then it's just the going column y. So going column x, I write down the coefficient. So the column x has a coefficient of 4 and 3. And then the coefficient of y has, the coefficient of y is r -2 and -5. and then you just cross multiply. So you're going to multiply, according to the rule of a 2 by 2 matrix, you multiply this. So you're going to multiply 4 by -5 minus the multiples of these two numbers, 3 and -2. Okay. So if you multiply those out, you get 4 times -5, which is -20, minus 3 times -2 is -6. So when you add these, when you have two negatives, it becomes a positive. So that's -20 plus 6, which is, find my calculator, found it. That's -14. So the determinant of this is -14. Okay, so how we need that number? We need that because to find the x value, to find the x unknown, you have to take the determinant in respect to x over the determinant of regular determinant, right? So we already have the determinant, which is -14, right? So you could divide this by -14. What we don't have is the determinant in respect to x. So I'll show you how to find that. So the determinant in respect to x is how you set the matrix is, do you see the x column and the x column in the coefficient 4 and 3? Well, you're not going to use 4 and 3. What you're going to do is replace those coefficient with the solution. So you're going to replace the x column with the coefficient 10 and 11. Okay, so that's going to be 10, and then this is going to be 11. And then the y coefficient is still going to be the same because we are taking it in respect to x, so that's why it's the same. So -2 and -5. So if you FOIL this out, so if you do, now you got to find the determinant. So it's 10 times, so it's 10 times -5, right? Minus -2 times positive 11. So what's 10 times -5? -50. Minus a -22, right? Because -2 times 11 is -22. Two negatives becomes a positive, so you're left with -50 plus 22. And that's going to be -28. Okay, so the x value is this is the determinant in respect to x, so it's going to be -28 over regular determinant, which is -14. And then -28 divided by -14 is +2. So your x value is +2. Okay, so that's how you find that. Now let's find the y value. So to find the y value, all you got to do is take the determinant in respect to y over regular determinant. So we already have regular determinant, which is -14. So let's find the determinant in respect to y. Okay, so the determinant in respect to y is going to be, so go back to your original equation. So we'll leave the coefficient for x the same as 4 and 3. But our coefficient for y will not be -2 and -5. It would actually be 10 and 11. Okay, so go ahead and multiply these out. So 4 times 11 minus 3 times 10. Okay, so go ahead. So that would be 4 times 11 is 44 minus 30. -3 times 10 is -30. So 44 minus 30 is 14. Okay, so to find the y value, it's the determinant in respect to y, which is +14. And then the regular determinant is -14. Okay, so your y value is actually going to be -1. Okay, so your solution is x equals +2 and y equals -1. Okay, so that's how you do it with finding two unknowns. So now let's do an example where you have to find example 2. So it says Use Cramer's rules to solve the system of linear equation with three unknowns. So, okay, so it's a little bit different because the determinant is a little bit more work. So let's first find the matrix for just regular determinants. So starting with the x column, I'm going to list the coefficient going vertical. So on the x column we have -1, +2, and 3. And then on the y column we have a coefficient of 2. And then over here we have nothing, so you just replace that with 0. And then over here we have -4. And then over here we have a coefficient of -3, 1, and 4. Okay, so what we're going to do is going to find the codeterminant. So what you do is first you're going to use this coefficient, which is -1, and then we've got to find the matrix of that. So what you're going to do is visually in your head or with a pencil or with your fingers or with like a paper, erase, eliminate anything that's related with that has rows or columns of -1. So what you're going to do is ignore this row because this has a -1, and then ignore this column. So you're left with 0, 1, -4, and +4, right? Okay. Then it's going to be minus because that's what they said. If you go back to the determinant of a 3 by 3, you have to do the minus. It's always a minus of the second coefficient. So it's going to be minus, and then our coefficient of the second one would be 2. Okay. Do the same thing like with the -1. You're gonna eliminate anything that has columns or rows of twos. Of this 2, not just regular 2, but this 2. So you can eliminate this row, this column, and then this row, right? So what are you left with? 2, 1, 3, and 4. Okay. And then plus the last term is -3, so it's actually really just a negative. And then what you're going to do is eliminate any rows or columns that has this number. So eliminate this row and eliminate eliminate this column and eliminate this row. So you're left with 2, 0, 3, and -4. Okay. So now let's do some algebra. So over here, starting with this part, -1, and then that's going to be, I'm going to do this in my head kind of, so it's going to be -1, and then 0 times 4 is 0, and then 1 times -4 is -4. So it's a -4, right? So if you're curious, what I did was I did -1, and then I multiplied 0 by 4 minus -4 times 1. That's all I did. So that gives us, so this is 0, right? And then, yeah, 4 times 0 is 0. So make sure you put, and then a minus 4 is 4. So that's like saying 4 times -1. Okay. Now let's do this part. So this would be -2. And then I'm going to just do this in my head. 4 times 2 is 8 minus 3 times 1 is 3. Over here, plus a -3. So 2 times -4 is -8 minus 3 times 0 is 0. So this is -2, and then 8 minus 3 is 5. And then over here, this is a plus -3, and then -8 minus 0 is -8. So let's simplify. -1 times 4 is -4, plus -2 times +5 is -10, plus -3 times -8 is +24. And when you put that all together, you should get 24, -10, and a -4 will give you +10. So this is just your regular determinant. Okay, so you know the rule. To find the x value, you have to do the determinant in respect to x over regular determinant. So let's find the determinant in respect to x. So go back to your original problem, right? In respect to x, you're not going to use the original coefficient of -1, 2, and 3 for your x column, right? You're going to replace that with the solution of 1, 0, 2. Okay, so this would be, hold on, let me go down. This would be 1, 0, 2, and then the y column, the y coefficient stays the same, so that's 2, 0, -4, and this would be -3. And the z column of original coefficient stays the same, so -3, 1, and 4. Okay. So let's find the determinant. So this one is going to be 1, and then remember, just erase anything rows or columns related to this one. So you're left with, let me write that down, 0, 1, and then -4, +4. Okay. Now the second term, which is 2, but make sure it's a minus, and then delete any rows or columns related to this 2. So you're left with 0, 1, 2, and 4. Okay. And then the same thing with -3. So the last term is, so it's going to be plus -3. And then this would be, so delete any rows or columns with this 3. So you're left with 0, 0, and then 2, -4. Okay. So let's start finding the determinant. So this is 1. And then 0 times 4 is 0, minus, and 1 and a -4 is -4. This is -2. And then 0 minus 4 is 0, minus 2 times 1 is 2, plus -3. 0 times -4 is 0, minus 2 times 0 is 0. Okay, let's simplify. So this is 1, and then a 0 minus a -4, that's +4, minus 2, and then 0 minus 2 is -2, plus -3 times 0. So 1 times 4 is 4, -2 times -2 is +4, plus 3 times 0 is 0. Okay, so that gives you 8. So the x value is determinant in respect to, so this is the determinant in respect to x, which is 8, over the regular determinant, which is 10. And then that could be reduced by at least 2, so that would be 4. 8 divided by 2 is 4, and then 10 divided by 2 is 5. So your x value is going to be 4/5. Okay. So we found the x value. Now let's do the same process to finding the y value. So find the y first. To find the y value, you gotta do the determinant in respect to y over regular determinant. So let's first find the determinant in respect to y. So let's set up our matrix. The x coefficient of the original equation stays the same. So our original x coefficient was -1, 2, and 3. Our y coefficient, that's where you change it. You're not going to replace. You're going to replace it. You're not going to use 2, 0, -4. What you're going to do is replace the y coefficient with the solution of 1, 0, 2. This is 1, 0, 2. And then your z coefficient stays the same. So it's -3, 1, and +4. Okay. So, okay. So now what we're going to do is find the matrix. So this would be -1, and then let's set up the matrix. So what you could do is erase any rows or columns with -1, so you're left with 0, 1, 2, 4, minus, this is a +1, right? So it's a minus a +1. And then the matrix is you're gonna delete any rows or columns with this 1. So you're left with 2, 1, 3, 4, right? And then it's plus a -3. And then over here, this would you delete any rows or columns that has this -3, right? So you're left with 2, 0, and 3, 2. Okay. So now let's simplify. So this would be -1, and then this would be 0 times 4 is 0, 2 minus 2 times 1 is 2, okay, minus 1, and then 4 times 2 is 8, minus 3 times 1 is 3, parentheses, and then plus a -3, which is 2 times 2 is 4, and then minus 3 times 0 is 0. Okay, simplify this. This is -1, and then 0 minus 2 is -2. And then this is -1, and then 8 minus 3 is 5, plus -3, and then 4 minus 0 is 4. So let's simplify. This would be -1 times -2 is +2. -1 times 5 is -5. -3 times 4 is -12. And then when you put it all together, you get 2 plus -5 plus -12 is -15. So this is the determinant in respect to y. So your y value is dy over d. So our determinant in respect to y is -15. And then just the regular determinant is 10. So this can be simplified as at least 5, right? So you're left with -3 over 2. So your y value is -3 over 2. Okay. Okay, now let's do the same thing for the z column. Okay, so the z is basically dz respect to d, and I mean the determinant in respect to z over regular determinant. So our coefficient for the x column is the original one from the original problem. So that was -1, 2, and 3. And then your your coefficient for y is 2, 0, and -4. And then the only thing you change is the coefficient of z, which is no longer going to use 3, 1, 4, but you're going to replace that with the solution, which is 1, 0, 2. Okay, so first let's find gotta find just the regular determinant, right? I mean, not the regular determinant. This is dz, sorry, yeah. So it's gonna be -1, and then so set up your matrix. So -1, and then delete delete any rows or columns that has this -1, so that you're left with 0, 0, and then -4, +2. And then over here we have a 2, and then remember you always have to put a minus. You always have to subtract the the coefficient of that. So it's -2, and then you're gonna you're gonna eliminate any rows or columns that related to this 2. So you have a leftover of 2, 0, 2, 0, and 3 and 2. Okay, and then the 1 is +1. And then what you're gonna do is replace or delete any rows or column with this 1. So you're left with this and then this. So you're left with 2, 0, 3, and -4. So this is -1, and then to find the matrix of this. This is 0 times 2 is 0 minus 1 times -4 is -4 minus 2, and then 2 times 2 is 4 minus 3 times 0 is 0 plus 1, and then 2 times -4 is -8 minus 3 times 0 is 0. So you're left with -1, and then this would be 0 minus a minus 4, that's 4, minus 2, and then 4 minus 0 is 4, plus 1, and then -8 minus 0 is -8. So this is going to be -4, -8, and -8. So what is that going to be? I think I made a mistake right here. So -1. So you're left with 0. Oh yeah, I did make a mistake. Just over here, with the coefficient -1, this is 0, and then this actually should be 0. So it's actually saying 0. 0 minus 2 is 0, and then -4 times 0 is 0. So this should be a 0, which is, and then this should be a 0. So 0 times -1 is 0. Okay. So now you're left with 0, -8, plus a -8, that's -16. So the determinant in respect to z is -16. So your z number is dz, which is -16, over regular determinant, which is 10. And then that can be reduced by -8, 2, which is -8, and then 10 divided by 2 is 5. So your z column, your z value is -8 over 5. So your final solution is going to be x equals 4/5 and y equals -3/2, and z would be -8/5. Okay, so I guess that's it. We'll call it a day, and you have a great day. Bye-bye.